Today on 6.4, we are going to talk about the dot products in vectors. If you could think of what a dot product is, imagine you have one vector, or let's say the vector is a car. Not a very good drawing car, but a car nonetheless. Say you are in a race car track, and then the car is going this way. And you go over, if anyone have seen Mario Kart, a boost. And the boost is going a different angle, but it is kind of going in your angle, in your direction a little bit. The dot product, even though you may not get the full boost, you're still gonna go a little bit faster that way. If you were to run over a boost in the exact same direction as the arrows, you would get a significantly larger boost from your little car over this, and it'd just be so much longer. So that is what the dot product is. Imagine your vector being one car, and then the boost being a U, or your car being a U and the vector being a U. So this is you, your car, landing on a vector. Dot product happens, zoom, and that increases your magnitude and your velocity in one particular direction that you are heading to. So that's what a dot product kind of does. So let's find the dot product first. So let's say we have U. We want to find the dot product of U and V. And let's say U equals -4, 6, and V equals -2, -7. Then the dot product of U times V equals, we just take the components and we multiply them together. This component multiplies with that. So -4 times -2, and then we add them. Plus 6 times -7, which gives us +8, plus -42, which is overall positive or -34. So the dot product is -34. Let's go on, do another example. Let's say we have 3U dot product V. So U is being multiplied by the magnitude of 3, and we want that for multiply with the vector U. Well, first things first, let's say U is 6, 7, and V is -2, 6. To find 3.U, what we need to do, what we can say is that this is the same thing as saying 3 times the dot product of U times V. So we can find the dot product first, and then we multiply everything by 3. So the dot product is 6 times -2 plus 7 times 6. This gives us -12 plus 42, which equals 30. Well, then 3 of that, 3U dot product V equals 3 times 30, which is 90. Let's do an example with 3 vectors. So let's say one vector U is at 3, 3. Another vector V is at -6, 2, and a third vector W is at 7, -3. And let's find out, let's say they want u times the dot product of 2v times w. So there is a lot going on here, but we can break this down one step at a time. So let's look at the parentheses. This is the equivalent to saying u times 2 times the dot product of u times v, which is, we can find that easily, which is 2 times 3 times negative 6 plus 3 times 2. Simplify that more. That is 2 times negative 18 plus 6, which is 2 times negative 12, gives us negative 24. So this first whole part is negative 24. If we rewrite that, that is negative 24 now times w. So now we just take negative 24 times the components of w, which is negative 24 times 7, negative 24 times negative 3. So what we actually end up with is, instead of a number, if we end up with one singular number, it is a scalar. But so back up here, this, our answer here, is a scalar. Whereas if we end up now with components, we end up with a vector answer. So our answer is actually a vector. So here, negative 27 times 7 is negative 168, and negative 24 times negative 3 is positive 72. So we end up with this vector as our answer. Let's try another example. What if we had u equals 5 comma 5, v equals negative 6 comma 3, and w equals 5 comma negative 1. And they want us u plus v dot product 0. Well, we know what u plus v. We just got to add that first, the components. 5 plus negative 6, that gives me negative 1. 5 plus 3, that gives me 8. Dot product 0, well, that is just negative 1 times 0 plus 8 times 0. Isn't that just 0? Our answer is just 0. And it's scalar because it's only one number. Okay, let's say we want to find now the angle between the two vectors acting upon each other. So let's say u equals 5 comma 6 and v equals 3 comma 0, and we want to find theta. Here, the formula for theta here is cosine of theta is the dot product of u and v divided by the magnitude of u times the magnitude of v. So that seems like a lot, but we know how to find each and every single component now. So here, u times v, so that gives me on the top 5 times 3 plus 6 times 0, and in the bottom, the magnitude is 25 squared. I'm going to do u first, so 25 plus 36 for u times v is what, just 9? We can do that. This is 15 all over 25 plus 36. That's the square root of 61 times what, 3? So 3 root 61. If I simplify that, I'll put it in my calculator. This should be 0.64018. So to find theta, we just take the inverse cosine of that. So inverse cosine of all this gives me 0.88 degrees. So that is my theta between the two vectors. Lastly, how can we tell if a dot product if two vectors are orthogonal. Orthogonal is just a fancy word of saying they are perpendicular. So if two dot products, so let's say you have a car going this way and the car, right? Your car is going this way and the boost is going straight up. That perpendicular boost is not going to help you whatsoever move your car further forward. So an orthogonal dot product will have a result of 0 because there will be 0 boost. So the dot product shall be 0. So let's say u equals 30 comma 9 and v equals 1/2 comma negative 5/3. Let's see what we get with the dot product. So the dot product says 30 times 1/2 plus 9 times negative 5/3. This gives me 15. 9 times divided by 3 is 3. This is negative 15. This is 0. So actually these two vectors are perpendicular to each other and they are orthogonal to each other.